Charlie Nicholson. Alexander Perez. He's online, right? Gerardo. Zach. Michaela? No. Chloe. Maybe by December I'll have it all done. We'll start in a couple of minutes. Okay, it's 8 o'clock. We'll start. Today in section 3.2, parts A and B, we'll talk about the slope of a line and graphing linear equations with slope. So we already know some things about graphing linear equations, and we'll learn even more today. Okay, at the top, in the XY plane, every non-vertical line has a slope. And the slope of a vertical line is undefined for the same reason that division by 0 is undefined. The slope of a line in the XY plane is defined as rise over run. So we can draw a picture of the XY plane. And here's a straight line. So if I pick any two distinct points, two different points on the line, then the slope of that line is rise over run. So on a straight line in the XY plane, as long as it's not a vertical line, it doesn't matter which 2 points I pick, the slope will always be the same. So between these 2 points, we define the run as the length of this horizontal line segment. That's a horizontal movement. And the vertical line segment is the rise. And so the slope is just the rise, whatever that happens to be, divided by the run. Rise over run. Okay, in order to find the slope of a line, of a non-vertical line, all that is needed are the ordered pairs of 2 different points on the line. So we have a slope formula based upon the definition that slope is equal to rise over run. So we'll look at the formula and then apply it a few times. The slope of the line that passes through the points x1, y1 and x2, y2 is m equals, in the numerator, y2 minus y1, and then over, in the denominator, x2 minus x1. So this satisfies the rise over run definition. A difference in y coordinates is a difference in vertical movement, or rise. And the denominator, x2 minus x1, that's a horizontal measurement, which corresponds to run. So this is rise over run. Okay, we'll use the slope formula to find the slope of the line that passes through each pair of points in this exercise. It doesn't matter which ordered pair you label x1, y1 and x2, y2. You'll get the same slope regardless of how you pick x1, y1 and x2, y2. Okay, so we have 2 points on a line. One is the ordered pair 0 for x, negative 9 for y, and the other one is 7 for x and 6 for y. Okay, so the slope of the line, if I pick my y2 to be negative 9, and then minus y1, negative 9 minus 6, then that forces me to pick x2 to be 0 in the denominator, so 0 minus 7. And then we just do the arithmetic, and always be careful when negative signs and subtraction is involved. So negative 9 minus 6 is negative 15. 0 minus 7 is negative 7. But we simplify this further because negative 15 divided by negative 7 is positive 15/7. Okay, so that's the slope of the line that passes through those 2 points. Okay, then in the next one, next pair of points, find the slope of the line that passes through the points 0, 8 and negative 8, negative 2. Okay, it doesn't matter which one you pick as x1, y1 and x2, y2. With some practice, you'll perhaps learn how to avoid more complicated arithmetic. But regardless, make sure that you know how to do the arithmetic. Okay, so in the numerator, I'm going to write 8 minus negative 2. And then in the denominator, 0 minus negative 8. And then do the arithmetic. 8 minus negative 2 is equivalent to 8 plus 2, which is positive 10. And 0 minus negative 8 is equivalent to 0 plus 8, or 8. And then we want to write fractions in lowest terms. 10 over 8 reduces to 5 over 4. So the slope of the line that passes through those 2 points is 5/4. Okay, one more example. Find the slope of the line that passes through these 2 points, negative 3, 4 and negative 5, 4. Okay, so in the numerator, the difference in the y-coordinates, 4 minus 4, and in the denominator, -3 minus -5. In the numerator, 4 minus 4 is 0. In the denominator, -3 minus -5, that is equivalent to -3 plus 5, which is 2. But 0 divided by +2 is just 0. So 0 is a perfectly fine number. The slope of the line that passes through those 2 points is 0. So what kind of line is it that passes through those 2 points? It's a horizontal line. If you were to plot those 2 points and draw a straight line through them, then you would find that it's a horizontal line. So in the xy plane, every horizontal line has a slope of 0. And that seems to make sense. If it's a horizontal line, there's a run because you're moving horizontally, but the rise, there's no rise. It doesn't go up and it doesn't go down. Usually, I guess in our regular vernacular, we think of rise as something that goes up, but we can also have negative slopes. It's just none of our examples have been negative slopes, but we can have a negative slope. If we go back to this picture up here, one thing that will be useful in the xy plane, if a line goes uphill as you look at it from left to right, then the slope is positive. So I'll just make a note of that. The slope, in this picture, the slope is greater than 0. But we can have slopes that are negative. If you have a line in the xy plane that goes downhill as you look at it from left to right, then the slope is negative, or we could say the slope is less than 0. Okay, let's do a couple of problems similar to what we've done already in the last class sessions. But we'll, in addition to graphing each line, we'll also find the slope. That's going to be convenient because in order to graph a line, we need 2 points, 2 ordered pairs of points. And in order to find the slope, we just need 2 ordered pairs of points. So we'll find 2 ordered pairs, we'll sketch the graph, and then we can use the same ordered pairs to find the slope using the slope formula. Okay, so let's just pick a couple of points. There are infinitely many points to choose from. We just need to find 2. If you want to pick x to be 0 and find the y-intercept, when x is 0, just replace x with 0 in this equation, and we get 7y equals 7 or y equals 1. Okay, so the ordered pair 0, 1 is a point on the graph. That's the y-intercept. If you want to find the x-intercept, then we replace y with 0. And when we replace y with 0, we get 3x equals 7 and then divide both sides by 3, x is 7/3. Well, fractions might not be the most desirable thing, but 0, 1 is about right here. Well, 0, 1. And 7/3 is 2 1/3. So about right here, 7/3, 0, and then draw a straight line through those. So what does the graph tell us about the slope, even though we haven't found the slope yet? It's going to be negative. If we graphed the line correctly, the line is going downhill as you look at it from left to right. So that means if that's the correct graph, then the slope has to be negative. So if you do the arithmetic to find the slope and don't come up with a negative number, if you come up with a positive number instead, then that's one of those warning signs. Something isn't correct. Either the graph is incorrect or the computation of the slope is incorrect. Okay, but let's use the ordered pairs 0, 1, and 7/3, 0 to find the slope. So in the numerator, I'm going to write 1 minus 0. So the y-coordinate of the first point minus the y-coordinate of the second point, 1 minus 0. And so since I made that choice for the numerator, I have to pick 0 minus 7/3 for the denominator. And 1 minus 0 is 1, and we're dividing by negative 7/3. So this gives us a chance to review some fraction arithmetic. 1 divided by negative 7/3, that is equivalent to 1 times the reciprocal of negative 7/3. So I'll say that again. 1 divided by negative 7/3 is equivalent to 1 times the reciprocal of negative 7/3. The reciprocal of negative 7/3 is negative 3/7. And 1 times negative 3/7 is negative 3/7. So the slope of this line is negative 3/7. Okay, let's do the next one. 3x minus 6y equals 12. So we'll find two ordered pairs, plot the two ordered pairs, and graph the line. If we use the x and y intercepts again, like we did on the previous one, well, in a case like this, that's probably the most convenient thing to do. If we pick x to be 0, then in the equation, when x is 0, we're left with negative 6y equals 12. And then divide both sides by negative 6, we get y equals negative 2. So our y-intercept is the ordered pair 0, negative 2. So how do I know this is the y-intercept? Because the x-coordinate is 0. Anytime the x-coordinate is 0 in the ordered pair, that's the point on the y-axis that the graph crosses or intersects. So that is the y-intercept. We can find the x-intercept by replacing y with 0, because every x-intercept has a y-coordinate equal to 0. And then in the equation, when you replace y with 0, we're left with 3x equals 12. Divide both sides by 3, we get an x value of 4. So the x-intercept is the ordered pair 4, 0. Okay, so we can plot those 2 points. So 0, -2, and 4, 0. And then draw a straight line to those 2 points. This line is going uphill, so if the graph is correct, then the slope is positive. So we use the slope formula to find rise over run. Okay, one way to find the slope, in the numerator, we can write -2 minus 0. -2 minus 0. And then that means we have to use 0 minus 4. -2 minus 0 is -2. 0 minus 4 is -4. -2 divided by -4 is +1/2. Okay, let's find the slope using the ordered pairs in the other order. So in the previous one, I picked -2 minus 0 divided by 0 minus 4. We can do it the other way around. Instead, I can write 0 minus -2 in the numerator. And then in the denominator, 4 minus 0. 0 minus -2 is the same as 0 plus 2, which is +2. 4 minus 0 is 4. 2 divided by 4 is 1/2. So if you had any doubt, hopefully this will remove it. As I said earlier, it doesn't matter which ordered pair you pick as x1, y1, and which one you pick as x2, y2. Either way, you get the same slope, same number. Okay, let's go on to the next page. So this is something we haven't done yet. This example is going to show you that you can graph a line if you know the slope of the line and an ordered pair of one point that's on the line. So the key in this case is to remember that slope is rise over run. Okay, so graph the line in the xy plane whose slope is m equals 3/4, and which passes through the point 2, 1. So a comment about the notation. Lowercase m is frequently used to represent the slope of a line, so that's why I'm using m equals 3/4 for the slope. Okay, so to graph this line using the point and the given ordered pair and the slope, the first thing we do is plot the point. So I'll number these tick marks. Hey, the ordered pair 2, 1, 2 for x and 1 for y, that's this one. So I'll label it 2, 1. Here the slope is 3/4. So we can think of the slope in a couple of ways that are equivalent. We can think of this slope as having a rise of +3 and a run of +4. If you prefer, you can think of the slope as having a rise of -3 and a run of -4. So you'll agree that +3/4 is the same number as -3 divided by -4. I'll show you what I'm getting at here in a minute. Let's use the positive slope first. So from this point that we know is on the line, we're going to rise +3. So that means from this point, we move vertically upward 3 units. So 1, 2, 3. The run is +4. So it looks like I need more points here. Okay, so from 2, 1, we have a rise of 3. So 1, 2, 3. And if the run is +4, we move to the right 4 units. A rise of 3 and a run of 4. 1, 2, 3, 4. What's the ordered pair for this point? So the x-coordinate is 6, the y-coordinate is 4, so we can label it 6, 4. And then just draw a straight line through those 2 points. So there's our graph. Okay, if I don't want to plot the point 6, 4, I can go in the other direction. So let's label these on the negative y-axis, -1, -2, -3. From the point 2, 1, if I want to think of the slope as having a rise of -3 and a run of -4, I can do that. So from this point, 2, 1, if the rise is -3, that means move vertically downward 3 units. So 1, 2, 3. 1, 2, 3. So now we're at this point. And if the run is -4, that means move to the left 4 units. Okay, so from here, a run of -4, move to the left 4 units. 1, 2, 3, 4. What's the ordered pair of this point? Yeah, -2 for x, -2 for y. So -2, -2. But it's on the same line. Our graph might not be extremely accurate, but it's believable. It's believable enough, anyway. So whether you pick a point going in one direction or the other, you still are graphing the same line. See how that works? Okay, the next one is same sort of exercise. There's a little bit of a twist to it, not really, but something to keep in mind. Graph the line in the xy plane whose slope is m equals -3 and which passes through the point -6, 1. Okay, so let's draw the XY plane. So the point -6, 1. Okay, the ordered pair -6, 1 is right here. -6, 1. Okay, the slope is given to be -3, but what does that mean if you think of rise over run?
-3/1.
Yeah, -3/1. So this is the thing that I was referring to. Think of slope as rise over run. So if we're just given an integer like -3, that means the same thing as -3/1. So this might help us avoid a mistake. If the rise is -3 and the run is +1, we can find another point on the line. So from the given point, -6, 1, if the rise is -3, it means move vertically down 3 units. So we're going to move vertically down 1, 2, 3. And then the run is +1. We move to the right 1. The x-coordinate of this point is -5. The y-coordinate is -2. So then we just draw a line through those 2 points. Okay, so that concludes that problem. Okay, the next example, another one of the same sort. Graph the line in the xy plane whose slope is m equals -5/6, and which passes through the point 1, 5. Okay. Okay, so the ordered pair of 1, 5. It's about right here. Here's where 5 is. So this is the ordered pair of 1, 5. And the slope is -5/6. And you can interpret it as as -5/6. Or if you prefer, you can think of it as +5/6. So the way that I've graphed this, it looks like using the first one, -5/6, is more convenient. I'll point out why that's more convenient in a second. So if the rise is -5 and the run is 6, from this point, 1, 5, a rise of -5 means move vertically down 5 units, so 1, 2, 3, 4, 5. Then move to the right 6 units, 1, 2, 3, 4, 5, 6. We're at this point. So this ordered pair is 7, 0. And then we draw a straight line through those 2 points. If we use the other slope, a rise of 5 and a run of -6, well, if I had drawn the graph a little bit differently, then to compensate for this, that would have been fine. But as it is, from this point, if I have a rise of 5, then I'm going to get off my grid. A run of -6 is to the left. So using this slope with my graph gets us off the grid, if you see what I mean. Okay, let's look at some other exercises. Okay, this one says, graph the line 3x plus 2y equals -2 using the slope and the y-intercept. Okay, so how do we find the y-intercept?
Move 0 for x.
Yeah, replace x with 0 and solve for y, because every y-intercept has an x coordinate of 0. So, all right, when x is 0, we can solve for y. When x is 0, we get 0 plus 2y equals -2, or 2y equals -2, so y equals -1. And the y-intercept is the ordered pair 0, -1. Okay. Well, if we follow the directions as given, we need to find the slope. So how are we going to find the slope? Well, we need another ordered pair to find the slope. So we already have one ordered pair, 0, -1. So find another ordered pair, then we'll use the slope formula. Okay, so find another point. Find another ordered pair. So which ordered pair do you want to find? There are infinitely many to choose from. I'll just say I'm going to pick x to be 2. When x is 2, we get 3 times 2 plus 2y equals -2. Solve this equation for y. So we get 6 plus 2y equals -2. Subtract 6 from both sides, we get 2y equals -8. And then divide both sides by 2, we get y equals -4. Okay, so the other point on an other point is 2, -4. Okay, then we'll find the slope of the line that passes through 0, -1, and 2, -4. So in the numerator, I'm going to write -1 minus -4, -1 minus -4. And then in the denominator, 0 minus 2. -1 minus -4 is -1 plus 4. 0 minus 2 is negative 2. And then finally, negative 1 plus 4 is positive 3 divided by negative 2 is negative 3/2. Okay, well, I ran out of room, but we did find the slope is negative 3/2. I'll leave the rest of this for you to do. We have two ways that we could graph the line because we have two different ordered pairs. So one way to do it is plot the two ordered pairs and draw a straight line through them. The other way, just like the previous examples, we could plot the y-intercept and then use slope, rise over run, to find another point. See what I mean? Okay. The next example has the same directions as the one we just did. So we'll bypass this one and look at the one on the bottom. Okay. Part 1, find the slope and the y-intercept of the line 3x plus 2y equals negative 2. Then we'll solve the equation for y, and then if there's room, we'll graph the line. But we're getting pretty good at graphing lines, so you can do that part if we don't get to it. Okay. This is the same equation as we found up here. 3x plus 2y equals negative 2. So we already found the slope. So down here, I'll just write that the slope is negative 3/2. Then find the y-intercept. We already found that. So if you look at your paper at the top, we already found that the y-intercept is 0, negative 1. Okay, so we already did that work. Okay, but now let's solve this equation for y. So I'll rewrite the equation, 3x plus 2y equals negative 2, and solve for y. So first subtract 3x from both sides, and we get 2y equals negative 3x minus 2. Then divide every term on both sides by 2. 2y divided by 2 is y. Negative 3x divided by 2 is negative 3/2 x. And then minus 2 divided by 2 is 1. Okay, the purpose of this exercise is to show you that when you solve a linear equation in the variables x and y for y, so y is by itself, the coefficient of x is the slope. So the number in front of x is the slope. This is m equals 3/2, the slope. And the number here, where it's minus 1, but you can think of that as adding negative 1. So this number is the y-coordinate of the y-intercept. So this number is the y-coordinate of the y-intercept. So I'll make a note of that. the y-coordinate of the y-intercept. And then you automatically will know that the x-coordinate of the y-intercept is 0. Okay, so this equation, y equals the slope m times x plus a number b, this is called the slope-intercept form. Slope-intercept form. Because if you have y equals mx plus b, the coefficient of x is the slope. So m is the slope. And the intercept part of the term means that this number that you're adding, plus b, this is the y-coordinate of the y-intercept. Okay, tomorrow we'll talk more about the slope-intercept form. So I'll leave this problem, I'll leave this for you to do. This is like the one that we just looked at. Find the slope and the y-intercept of this line, 4x minus 3y equals 6. Solve the equation for y, and you'll note when you solve it for y, you'll have it in the form y equals mx plus b. And the coefficient of x will be the same as the slope. And the plus b will be the y-coordinate of the y-intercept. Okay, so we have a couple of minutes left. Let's graph these lines, x equals 6 and y equals 1 in the same xy plane. So in the same xy plane, okay, the line x equals 6, that is a vertical line in the xy plane. It is the line on which every point has the same x-coordinate of 6. So this vertical line is x equals 6. It's a vertical line. Y equals 1. This is a horizontal line. On the horizontal line, every point has the same y-coordinate of 1. So the equation for that horizontal line is y equals 1. This is horizontal. Okay, we're about out of time for today. Tomorrow we'll also be in section 3.2. And we'll also, if there's time, we'll go back and look at some of these other problems that we didn't do completely. Okay, but that's all for today.